In this video, we're going to talk about some key points of a polynomial function. So this could include the extrema, relative or absolute maximum and minimum, so various turning points within our function. And then in another video, we will talk about the end behavior to kind of tie all those key parts of a polynomial function together. So we're going to look at mostly a graph, but also a table, and try to identify or estimate some of these key parts of our function. So extrema, that term is just talking about altogether the relative minima, relative maxima, and turning points of a graph. Now you might see this and think, shouldn't it be minimum and maximum? So minima and maxima are the plural version of minimum and maximum. So you may have more than one relative minimum or relative maximum. So turning points, that kind of also relates to relative max and min. So what those represent are, as the function is graphed and we're following it along, we see some change of direction, curve, where no other nearby points are greater or less than that point. So relative max doesn't necessarily mean the maximum point or value in the entire graph. It's just in a certain area, there is a clear maximum point in that area, and so no other nearby points have a greater y value than that specific point, which is going to be referred to as the relative max. Same thing with relative min. No other nearby points have a lesser y value. The absolute maximum and absolute minimum, that's the greatest y value in the entire function, or for minimum, greatest or the lowest y value in the entire function. So we'll take a look at what the difference is between those two, and then consider the end behavior as it goes to positive infinity or negative infinity. So if the end behavior doesn't level off at a specific constant, it goes up forever or down forever, then there is no absolute maximum or minimum, depending on which one. Okay, so let's take a look at an example. All right, so in this graph here, we see there's two changes of direction. So it goes up, curves, starts coming down, curves, and goes back up again. And these endpoints here really should have arrows, right? There's a lot of graphs that they just don't have arrows on them when they graph it. So different applications or software don't include that. It just, the graph goes to the end of the screen or the end of your window here. And so we know that it's going out forever. So the absolute, I'm going to skip to the absolute here. The absolute maximum, well, that's the highest point up here, but this goes forever. So the absolute maximum, there is none because it goes to infinity. Okay? Same thing with the absolute minimum. As we go to the left here, it's going to go down forever. So let me send this to the back here. So the absolute minimum is also non-existent because it goes to negative infinity. All right, now some polynomials will both ends go up to positive infinity. In that case, there's going to be an absolute max, but in this case, there's not. So now let's look at these turning points here. So there's two turning points. This one here, if you're just looking at this area right here, it's sort of like a parabola, right? And it's got this point at the top that, relative to its nearby points on a graph, it's a maximum, okay? So we have a relative max here, and we'll just say, we'll estimate its around x equals -2. Okay, so relative to the rest of the graph in this localized area, we have a maximum right here. Same thing here at this turning point, relative to the rest of the graph, or nearby graph, we have a minimum here at, it looks like it's just past x equals 1. So we'll say that it's around x equals 1. All right, now our zeros, those are just our x-intercepts. So zeros, roots, x-intercepts, those all represent the same thing. So I see it's in between a couple different values on our x-axis. It's going to be hard to get the exact value here. So again, we're going to just estimate what our zeros are. So I put in the values on our x-axis that are very close to our zeros. Again, we're just estimating here. So this one here is pretty close to -3. So we have 1 0 around x equals -3. We know it's a little larger, so maybe -3.3. Here, this one's a little less than -1, so it's close to -1. And then this one looks like it's halfway between 2 and 3, so I'll just say 2.5. Okay, now let's look at a table. Because a graph, it's a little easier to see some of those points. Now a table, we've got these different x values here. I'm just increasing by 1. And then our y values are kind of all over the place. So let's evaluate that. So our absolute maximum and our absolute minimum, we don't have enough information to answer those. So I'm going to take those off. But we can estimate our relative max, our relative min, and our zeros. So our relative maximum, that, remember, is when we've got a turning point. So our y values are going to increase, and then they start to decrease again. And that point where it changes direction, that's our relative maximum. So I see here I'm going from 11 down to 3. So I'm decreasing my y values. And then at some point in here, it starts to increase again. So it either increases before we get to this point, -1, 3, or it increases slightly after. So this is actually a relative minimum, right? So my y values are at 11, they go down towards 3, and now it's going back up to 6. So somewhere around this point, -1, 3, we have a relative min. Around -1, 3. Okay, so let's keep evaluating here. So now I'm going up to 6. So I've gone from 11 down to 3, up to 6, and then 7. So it's still increasing. And now after 7, now it decreases back again down to 2. So up here, we decreased to 3 and then increased again. So that was a relative minimum. Here we're increasing to 7 and then decreasing again after 7. So right here represents a relative maximum. So relative maximum, and it may or may not be that exact point. So it's going to be somewhere around 1, 7. So now I decrease from 7 down to 2, and it continues to decrease to -6 to -13. Okay, so this trend here continues to decrease. I can assume or guess that maybe it continues to decrease forever and goes down to -infinity. If that's the case, then it doesn't have an absolute minimum, but not enough information to tell that. So it looks like there's only the 2 turning points. And then there is only one time our y values change from positive to negative or vice versa, and that is between 2, 2 and 3, -6. So we definitely have a 0 there. It's definitely going to cross the x-axis. I'm first actually going to say it's between 2, 2, and 3, -6. Well, if my y value has to be 0 there for my 0, or for my x-intercept, it's more likely going to be closer to 2, 2. So if I had to guess between the two, if I had to estimate, I would say it's around 2, 2. Looking at that even further, though, a 0 is an x-intercept. So I'm going to guess that my x-intercept, my 0, is around x equals, and it's between 2 and 3, so I'll just say 2.5, right? But anything really in between 2 and 3, is a good estimate.